So we are all welcome again to this class on hypothesis and the different texts we have. We have three from our book. We have three tests. We have Z test, which is normal distribution. We have T test, they call it T student distribution, and then we have F test. So we are going to cover the three tests today. After the three tests, then the next class will be on chi-square and some other things. We'll look at chi-square. How do we calculate chi-square? See, I want to quickly say this. Don't say that it's going to be objective. I don't need to know all the calculation. Some of us have the mindset that no. Now, the question I want to ask you, after now, what next? What will you do after now if you don't do that now? So please, let's try as much as possible to also put that one into consideration. That if I'm not here again, what will I be using? Is that okay? So let's just try as much as possible to do it today. So let me share my screen. So as I told you, we have Z distribution, T distribution, and F distribution. They call it test distribution or any other things you can see in your book. But how do I know between between Z and T? When do I use T and when do I use Z? Be careful, we have different people giving different things, but the standard things you need to know is we use T test or distribution when n is less than 30. Then Z distribution or test when n is greater than 30. Please take note of that. Now, they can ask us about 1T test and 2T test, which we discussed yesterday, and I will also explain it again. When we have 1T, and go and read about the definitions. I may not be able to give you the whole definition now, but I can promise you I'll give you what you use to remember. Let's say hypothesis now. Under the hypothesis, you have, is either your hypothesis is 1T test or
your board is not showing.
Are we sure you are not seeing my screen?
We're not seeing it, sir.
You have to share, sir.
Oh, sorry about that. I thought I've shared. Can you see it now?
Yes, we can.
Oh, okay. Thank you. So we have this. I said when do we use T test is when n is less than 30, and we use Z when n is greater than 30. Take note of that. So in hypothesis, is either your hypothesis is one tail test or two tail test. At what point do we have one tail test? So anytime you have H naught, which is non-hypothesis, let's say mu is greater or equals to 0, and the alternative, which is our claim, is mu is less than 0. This is one tail. Now, at this point, we have one T. Let me just, at this point, we have one T. Now, the second one, when you have H naught and you have your mu is less or equals to 0, and the alternative is also mu greater than 0. This point too, we have one T test. But the last one, the last scenario that we normally have, H naught, mu, when you have it to be equals to 0, and alternative says my mu is not equals to 0. At this point, we have two T tests. Please take note of that too. So let me number it. Roman figure 1, Roman figure 2, and Roman figure 3. When do I need to accept for Roman figure 1? My Roman figure 1 is like this. Under my Roman figure 1, the middle is 0, is the bell shape. The middle is 0. Just trying to explain to you. This place is shaded, and it's alpha, and this is negative region. But both of them are symmetric. Symmetry means what is in A will also be in B. That is, what is in left will also be the one same thing in right. So let's take note of that. Then, but that's Roman figure 1 that we're working on. Roman figure 2, then at this point, we say we reject H naught if our T calculated, we call it calculated, the one we use formula to do, is less than negative alpha this, which is T tabulated. Then Roman figure 2. Because they can ask you, at what region do we reject? Please take note. Roman figure 2 says, B, our claim is greater than. Let's look at our claim. Our claim is alternative. So Roman figure 2, let's look at it. Can you hear me now? Can you hear me, please?
Yes,
Yes,
sir.
sir. We can hear
Okay,
you.
thank you. I'm just using the diagram to explain. Alpha means level of significance. Level of significance, level. That is our alpha. So at this point, This is Roman figure 2. Our T is the other side here. Then here we reject H naught if our T calculated is greater than T tabulated. Tabulated means the one you check in the table. From your alpha, you check it. But the third one, which is 1, 2, 3, says the both of them, they have both. That is 2T. You can see the 2 now. You have in the both, when you have both, your alpha will be divided by 2. Your alpha here will be divided by 2. You have negative T alpha over 2 and T alpha over 2. So at this point, what do? We reject at this point too H naught if T is less than minus T alpha 2 or T greater than T alpha 2. Is that okay now? So at this point, that is when we reject. Now, having laid all this foundation, I have posted something to you, different table. Some of us were confused. You don't need to be confused. I sent the table to you so that you can have idea of what the statistical table look like. And I'm not sure whether the school will provide one for you or not. I don't know about that. If they do not provide for you, it simply means the examiner will have give you the value of the tabulated value you need. I hope I'm communicating now. The value of what we need will be given to us. So let's look at this, the problem one after the other. We will start from confidence interval. Okay, they did not provide, no problem. You have access to the one I gave you. You can still use the one I gave you first for now, pending the time. So let's continue. Okay, let's look at the confidence interval. But before the confidence interval, what are the formulas for? I'll be writing the formula along the line. Just be writing it the way it is. So it will help you. I will use confidence interval as this. If they ask you to check confidence, they can give you a particular scenario and ask you to construct the confidence interval of that problem. Number 1, let's start. The average weight, students, in a certain school was found to be 165 pound. 165 pound. with standard deviation of 4.5. A, construct a 95% confidence interval for the population mean. Two, B, calculate or determine, let's say determine the margin of error call it EBM. Margin of error for the population. So how do we solve this one? Then solution will be, now the first thing I want you to do is how many students are we talking about here? In this case, we were given, sorry, I omitted something here. The average weight of 20 students, sorry, let's put 20 there, in a certain school. Is that okay? So now let's look at this. We can solve this problem now. The first thing you need to check is, let's analyze how many, we were given something. The formula to calculate this problem is for this type of, we are looking for the mean for A down. Is going to be, now, who can tell us which test are we using for this? Is it T or Z?
T test.
Why is it T test?
Because it's less than 30.
It's less than 30. Good. Then our interval will be, please just mute yourself. Once you talk, mute yourself because of the background noise. So we have it to be X bar plus or minus T plus or minus T but we call it confidence interval. Then now that we are looking for, we are not talking about, okay, alpha over 2, I'll come back to that. This is just the formula first. And if you check your books, they are there, but it's only that it's scattered. But let's look at this. Yes, Daniel.
Sorry, so the T, is that a R or a V?
V.
V, okay.
Degree of freedom.
Okay,
Degree,
thank you,
V means degree of freedom. degree of freedom. Now, in this case now, what is X bar from the question? Anybody? What is N? That's how you analyze it.
20.
N is 20. What is standard deviation?
4.5.
Then what is X bar?
X bar is 95%.
No.
165.
Now let's read the question. The average means the mean, right? Weight of the student in a certain school was found to be 165. That is, the S bar in this case is 165. Please take notes. Are you getting it now? Then for the degree of freedom, our V is equals to N minus 1, which is means what? N minus 1 will be what?
19.
20 minus 1, which is 19. That is your degree of freedom, which is equal to your V. Now,
Sir, how did we get our N?
N is there, you are given.
I'm confused.
Look at it. They said the weight, the average weight of 20 students, the number is 20.
Okay.
Are you okay now?
Okay, yes.
Okay.
Yes, sir.
Okay, let's continue now. So for confidence interval, we need to know alpha over 2 will be what? Because we were told to construct 95% confidence interval. The formula is alpha over 2 equals to 1 minus confidence interval divided by 2. What is our confidence interval? Anybody?
5%.
95%.
95%, which is 0.95.
0.95.
Divided by 2. What is it? It's 0.05 divided by 2, which is equals to what? Anybody? Do you agree with me? Are we on the same page?
Well,
All I did is just to divide, just take it.
so
Look at
minus
this.
and then divide by 2.
1 minus 0.95. 0.95 is the what we are given, 95%. Look at it. That's what they call the confidence interval. We are trying to construct the confidence interval now. Okay, let's move on. 1 minus 0. Okay, let me ask this question. In your class, did you do something on confidence interval?
She has already solved it.
So let's proceed. Let me share the screen again. Are you there now?
Yes, sir.
Yes, we are.
So at this point, can you please mute yourself?
It's not good for your body.
Okay, so we are given, they ask us to construct it. We don't know it. That's why you are just given the confidence interval, the percentage, then construct it for us. Within one range are we talking about? That is exactly what we are saying about confidence interval. Within so range and so range. So let's take notes. Okay, let's move on. We can now say that This divided by, now we have this one. If you divide this one, what do you have? You have alpha over 2.
0.025.
0.025.
0.025.
Good. Now, don't forget we know our V. By the time we get there, you will see what I'm driving out. But in this case, we are not talking about hypothesis now. We are just talking about confidence interval, which is the same thing as this. You have 1 minus alpha. You have alpha over 2. You have alpha over 2 here. But now, let's see. Our T is V, comma, alpha over 2. That is tabulated. This is what we call T tabulated. Now, we know our V to be what?
19.
Okay, T19, comma, 0.025. Now, let's go to our table. Can you see my table?
Yes, sir.
Yes, sir.
Now, the first one, okay, I think I sent one to you guys before now. I think we need to go and check that one. Let me open that one. Can you see this one now?
Yes, sir.
So let's go to T. If you have your own table, go to T distribution. T distribution, are we there?
Yes, sir.
Are we there?
Yes, sir.
So what are we looking for there?
0.02 under 0.5.
No. So what you are
So we're
looking
looking for 19.
look at it. Look at
Degree of
it.
freedom.
Look at this place now. Look at this side. You can see, what do they write here?
Degrees of freedom.
What number is our degree of freedom?
19.
Go to 19. Now, our 19 is here. It's a pity I didn't upload it on OneNote. This is 19. Can you see 19?
Yes.
Now, the level of your alpha is here. You see, they call it significant level.
Significance level.
Have you seen it?
Yes.
Now, our significant level in this case is 0. What? Which of them? Which of the column? Do you have 0.025?
No, sir.
No, sir.
Oh, really?
We don't.
Says who? Can't you
What
see
is-
2.5 divided by 100 is what?
2.5.
Now, wow.
Is there? Is there?
Don't say it's not there that day. These people. Okay. Oh.
Seeing it.
See, you see it in percentage. It simply means you have to convert it by yourself. Have you seen 2.5 now?
Yes, sir.
Second, sir, 2.5%.
Divided by
Yes.
100. 2.5 divided by 100 is what?
0.025.
Yes. Now go and look at it under 19. What is the value there?
The value is 2.093.
That is your value. Who is not clear to what I did? Raise up your hand. Let me see your hand now. Before I leave this page. Okay, it's clear to all of us. Okay.
Hello, sir.
The screen
Yes,
is
ma'am.
Now
complex.
all remain silent.
Yes,
Hello, sir.
yes, I'm hearing you.
Okay, if we go up, you see 1T and 2T,
Mhm.
and the 2.5 there is under 1T.
Under one tailed test.
Yes.
Yeah, I thought we are doing 2T test.
No, we are not doing. That's why I told you we are not talking about hypothesis now. The question does not ask us to state hypothesis. We are not working on that hypothesis now. All we want is confidence interval first. Are you getting it? Hello?
Hello, sir.
Are you getting me
So
now?
now that we have, there's 5. Yes, sir. But there is 5% up and there's 2.5 up. So that means that we can use 5% and 2.5% at the same time.
No. Just hold on. The two of them will give you the same value. Look at it. The way they do this table, they do it in such a way that your significance will still be your significance. The value will still be your value. Only the difference between this table is some table will give you 1 tail like this one and 2 tail. Why some will not give you? If I call the other one 2 tail, okay, let's go back to the slide, to the one. Okay, look at this now. When I was explaining 2 tail, let me show you there. I said divided by 2, right?
Yes.
Yes, sir.
When I was explaining 1 tail, what do I do? Do you divide it by 2?
Divided.
No.
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 You see that the same table cover for the 2. It simply means that if I divide this one by 2, if I don't divide it by 2, I will still have 0.05, which is 5%. Am I communicating?
Yes, sir.
Yes, sir.
Are you
Yes,
getting
sir.
what I'm saying now? It's still going to be the
Yes.
same value I'm going to get. Okay, let's say, let's check. We have the table now. Check T 19, 0.05. What's the value? Check it, please.
I don't have the table.
Same value.
It's the same value, sir.
The same value.
The same value.
0.093.
Do you have any 5% on top of 2K again, apart from that particular junction?
No, sir.
No, sir.
If you check the 10%, it's different in 2K in the other side. So please take note. But the major thing is we are not stating the hypothesis now. I'm just trying to explain how to construct the confidence interval first. Am I free to go now?
Yes, go ahead.
Okay. Now our T tabulated is equals to 2.0930. You will see in this case, we don't need to reject or accept anything. That is not where we are going. Now, let's go to our mean. Let's calculate the mean. What is X? Our mean says X bar plus or minus what? TV, comma, alpha over 2, S over square root of N. So our mean is tends to, what is X bar? Our X bar is what?
165.
165 plus or minus. What is T?
2.093.
Yes. Remember, everything here is already checked. That is 2.93. Now, what is standard deviation?
4.5.
So punch your calculator, what do you have? You have 165. Don't do it together, plus or minus. Just do this one and multiply by 2. What do you have? Nobody? We are waiting.
$2.106.
God bless you, sir. 2.106. So for 95% confidence interval, it simply means our X bar minus. Can you please mute yourself, please? Minus EBM or X bar plus EBM. Remember, the first question says A. The A says, construct the confidence interval for polynomial. Determine this magic. We are already determined this one. So, and that is why, where do we determine it? We determine it through the standard deviation or this side. That's what we did. So we are going to substitute it now. It's going to be, use your calculator, please. 165 minus 2.106 or 165 plus 2.106. So what is the answer now?
163.106 or
163.106.
106 or 167.
Are you sure of what you are calling for us?
Yes,
Be
sir.
careful.
163.106.
Okay. Then 167.106. So that is the interval we are talking about.
That first
Sorry,
one
the
is not
first
correct,
one.
sir.
The first one is not correct. It's
The first one is not up to
162.
163.
It's
162.894.
162.894.
162.894. So that is what they asked us to calculate. For an EBM is the same thing as TV, alpha 2 and S over square root of n. So we've done the two together. Any question? So if you have any question on this particular aspect, you should be able to solve it. How many of us have seen question on confidence interval before? You've seen it before. Look after it, check it. You will see the way they will put it down for you guys. So let's quickly move to, but in a situation whereby you are given the raw data, how do we do it? How do we do the raw data? Do I need to explain that one? Or that one is pretty clear, we can undo that. I need the confirmation. You said? What do you say, sir?
Explain to us.
Explain it, sir.
Oh, okay. You want me to explain?
Yes, sir.
Okay, it is number 2. Let's look at this. Okay, let's say, okay, Blessing, what do you say?
Sir, please, where is this 2.106 from?
Are you also in the market?
No, sir. I'm in the house.
Oh, okay. Cooking in the kitchen.
No, sir.
Okay, look at this. We got it from here. Look at it. You understand? Were you there when we got this one?
Yes, sir.
Then multiply everything together. It will give you this. With this. That is 4.5 divided by square root of 20. Multiply it with these two. Is it okay by you now?
Okay, sir.
Thank you. Okay, let's continue. We are asked to construct another, okay, a chemistry, let's write, a chemistry class at a certain, yes, any question? University has 500 students. The score of 10 students was selected at random and shown in the table. In the table below. Number 1A, calculate the mean and standard deviation of the sample. The mean and standard deviation of the sample. That means nobody will give you the mean in this case. B, calculate the EBM, we know it now. C, construct a 90% confidence interval for the mean score of all the students in the class, in the chemistry class. Okay, let's look at the table. We are given this table. 76, 89, 84, 73, 69, 67, 92, 85, 58, 77. So how do we solve this one? First thing is X bar, solution now. Let's calculate the X bar. X bar means mean. Please, every one of us, let's bring our calculators. You are to sum and divide it by number. That is summation of X divided by N, which is what? 76 plus 84 plus 69 plus 92 plus 77 divided by, how many N do we have? Please talk, guys. N is
Five.
what?
10. 10.
10.
N is 10. Thank you. So our X bar will be, if you do it very well, 800 divided by 10, which is equals to 80. Then we are to get the standard deviation. You remember the standard deviation in this case will be square root of, we did this in first semester, X minus X bar square over N minus 1. So how do we do it? Our X bar is what? S will be square root of, that is each of the X minus 80. That's what they asked you to do. 76 minus 80 squared plus 84 minus 80 squared plus
69 minus 80.
you do that 77 minus 80. You will get negative, but when you square the negative, you will become a positive.
Positive.
So you don't need to be scared. Divided by 10 minus 1. If you do this one very well, which I expect you to do after now, you are going to have standard deviation to be 11.709. 11.709. Don't forget your N is equals to 10. Then what is our X bar now?
Sorry, sir, before you go further, I think the table might not be complete if we have 800 as the final calculation for those data given.
How?
My calculator is giving me 770.
Check it again. Let's go back to the table. If that's the one we do, let's check the value. 76, 84, 69, 92, 58. Please, let's calculate
Yes,
this and get our X bar correctly. 89, 73, 67, 85, 77. What do you have? Yes, Muraina.
The X bar is 77, sir.
S bar is 77.
Yes, sir.
Yes,
Who
sir.
else again?
Yes, it's 7 divided by 10.
Who else?
Me, sir. 770 divided by 10. 77.
770 also, right?
Yes, sir.
How many number is missing? That means 10 is missing, right? Hello?
30, sir.
30
30 is missing.
30 is missing. Okay.
Yes, sir.
I don't want to disturb this. Let me just add 30 to somewhere.
So it's 89 and
We just,
77.
30 is
Oh,
missing,
103.
right? Call
Yes,
this
sir.
one 77, 95, 83. Do we have it correctly now? Please add it again. Friday, go ahead.
There is an hold answer.
Okay. So add it. Let's see whether we have 800 so that we can proceed.
Yes, sir. It's 800 now.
It's 800 now. Okay. So all you need to do now, all we need is just a technique. How do they do it? Okay, thank you. How do they normally do something like this? Now we have idea. When you are at home now, you are relaxed. Some of us are not going to work. Some of us are still working. Anytime, any day, sit down and do it by yourself. Whether you get 87 or 88, just know the way of solving it. I'm not promising you this is the question coming out. I'm only giving you the way to solve it. Just take note of that. Any Abimbola Tope, any question?
Yes. Oh, sorry, no.
No.
No question. I forgot to mute myself.
Okay.
So
Let's
please,
move
can
on.
you scroll down a bit? Have you scroll up a bit?
Do you need table or which one?
The table, sir.
Okay. So that's the way of solving it. Now let's move on to get our EBM. EBM now is what? The formula for EBM, let's say we call this one 80, right? Our EBM will be T V comma alpha over 2. So let's get the alpha over 2 is what? What is alpha over 2? 1 minus confidence interval over 2. What is confidence interval? 1 minus, how many percentage? What they said we should construct. We already have mean and this. We have to calculate this one. We have to calculate the B. But we know that we can't get B without 3. 90%. Let's go to 90%. 90% will be what? 0.90 divided by 2. So you have, what do you have here? 0.10 divided by 2 is what? You have your alpha over 2 to be 0.05. Any question?
No, sir.
Okay. Now let's look at CV. What is our V in this case? N minus 1. N minus 1 is what? 10 minus 1, which is 9. So we have it to be 9, 0.05. Can we go to our table? Everybody go to your table and look at it. 9, you have, don't forget this is 5%. You will see on top now. You see 5%. So I want to see who will, the way we are going to get this one. What is the value?
Some of us don't have the table.
Do you have the table?
Okay,
Can you see my
downloaded.
table? It's there on the screen.
Yes, sir.
So what is it?
2.62.
Is what?
2.262.
Where did you get that one?
From your table.
No, it's not from my table. It's not from my table. Look at it very well.
4.781.
Where do you get all those big values?
So we are looking at 5%. Oh.
5%
On that, now don't make mistakes. If I don't divide it, remember, if I don't divide this one, what will we be looking at? If I don't divide this one, what will I be looking at? Somebody talk, please. Is
We're
what?
looking at
10%.
1%.
God bless you.
10%.
You will be looking for 10%. But now I
Yes.
divided it into 2. If I don't divide
You're
it, that
looking
was
for
the question the
5%.
lady asked me the other time. So now let's go to the table again. So which one is the answer?
1.833.
1.833.
1.833. Thank you.
1.833.
1.833.
Madam, 4.333.
I'm not seeing it though.
Don't worry, you have the table. Just check it. 1.833.
1.833.
That is just how to check it. So we can substitute it into our EBM now. Our EBM now be 1.833 multiplied by standard deviation is what? 11 point what? 11.7. In case you solve your own, it's not the same. Just substitute. Divided by square root of 10. So what do you have now? Answer, please.
It's 0.787.
Yes, thank you. Plus or minus 6.787. So all we need to do is just to add and subtract. Then you have your value. It's just like 80 minus 6.787 and 80 plus 6.787. That's what they asked us to do. So when you add this one very well, you have 73.213, 86.787. So they can give you, this question is very simple in OBJ, in multiple choice, because they will just use comma to separate the option. If you are not the type that know how to solve this problem, you'll be in trouble. Okay, let's quickly check the hypothesis again before we jump into another thing. I only have a question on T distribution, F distribution. So can we please write this question down? Let me go to the question. If you have it, because the question is a bit too much. So let me just give us. Okay, can we write this question down, please? Just write the question. For those of us that are not there yesterday, write the question. And for those of us that you are sleeping where you are writing, write it again. You know yourself. Or should I be mentioning name now?
Yes, sir.
The ringleader said no. Now you have to cover them.
Blessing, congrats.
Yes.
You have to cover them. You have to protect them. Data protection. So let's write the question down. And once we write the question, then we will now solve it. Are we there now? Can I proceed, please?
Yes, sir.
No, sir.
No,
Yes
sir.
or no?
No, sir.
No, sir.
Yes, sir.
Okay. The way you said no, you say yes, so immediately when you are done. So that we can solve it together. Can we go? Going? Now, if you look at this question, it said a factory has a machine that dispenses 80 ml of fluid in a bottle. An employee believe the average amount of fluid is not 80. It's not 80 ml. Using sample he measured the average amount dispensed by the machine to be 78 ml with a standard deviation of 2.5. You know that you can only get standard deviation after you've gotten the sample. Do we agree with me?
Yes.
Then state the non-hypothesis.
Get out from there and get out.
And alternative, state the non and alternative hypothesis. B, at a 95% confidence interval, or confidence level rather, is there enough evidence to support the idea that the machine is not working properly? 95% confidence interval, confidence level. So now, what are the things we need to do? Let me go down. Okay, I think this is where we stopped yesterday.
Yeah.
Okay. Now we lay foundation now. Can I solve it here?
Yes, sir.
Yes, sir.
Okay. Now let me solve it. Now, how do we know? How do we state this? Somebody said, remember, if you want to analyze this statement, which one you call your claim? I need somebody to talk.
78 mil.
78 is your claim. Remember, he claimed that this is what I discovered. On a normal day, if the machine is working perfectly, which is our non-hypothesis, when they ask you to state something, to state the non-hypothesis, or how do you state the non-hypothesis of so thing? First of all, analyze it this way. What is the ideal thing that this thing is supposed to be doing? Are you getting it now? The ideal thing for the machine is to produce 80 ml. Some of us we work in different factories. Some of us have our own personal business. You know the ideal thing before you change the measurement. Or you know the ideal thing before, for example, somebody was telling me, let me just digress. How many of us normally eat pando yam?
Hi.
How many of us? Raise up your hand. Ogaya, correct. Who else? Raise up your hand. I will call your name.
Hi.
Better. I like the idea now. Okay. We have some people that are here. They are even the seller, but they will not talk. They did not eat it alone. They even sell it. Should we be mentioning our name?
No, sir.
Aha, you see them now. Okay, let's proceed. Before Pando Yam, they used to, according to people that sell it, I was told that some measurements has changed. The one you're supposed to buy 5 kg, now they are putting it 4.5 or 4 point something.
Yes,
Is it
sir.
possible? Is it like that?
Yes, sir, it is, sir.
Do we agree with that?
Everything
sir.
in Nigeria is possible, sir.
Now, we are using Pando Yam now without mentioning any brand. That, okay, it's supposed to be 5% or 5 kilogram. But now the Pando Yam is now 4.5. And they are still selling it as 5 kilogram. Maybe when you buy your own, some of us, we take the measurement. Some people are good at that. They will use the ruler to measure the yam before they cook.
Teacher.
Some people will have different cup for different cereal or for different food. Now, when it comes to Pando Yam, they still put 5 kg. And probably you have a measurement in your house. You know that this thing, let's use this cup. This cup supposed to be, let's say this cup now supposed to be 5 in Pando Yam. Now, as you are measuring it, you discover that, okay, you call your children, okay, you make sure you use 1 cup. They said, yes, sir. They use 1 cup first time, they use 2nd cup and 3rd cup. And you're supposed to buy, you get 5, and you eventually have 4 and a little. Does it mean you children, you are overeating the food? They said, no, it's still 1 cup. I said, okay, I will catch you one day. And the woman went back to the market and bought another Pando Yam. When you measure it by yourself, you discover that it's 4.5. That is what the scenario we are trying to portray here. Now I have 4.5. And the machine is telling me that it's 80 ml. Let's go back to the slide. So it's 80 ml. So after I've taken all the analysis, I can, as a worker now, as an employee now, concluded that no, this machine is giving us 78 ml. Now, we want to be sure that this man is also right. We now said, okay, state the hypothesis. State it. The man asked the manufacturer, the owner of the company, sir, what is this machine supposed to produce for us? He said 80, okay? If it is 80, it simply means our non-hypothesis is 80. That is, according to the manufacturer of this machine says, non-hypothesis, this machine will give you 80 ml. But according to my own principle, or according to my own research, as an employee, I said the machine is not equals to 80. This is my own claim. This is my claim. That is, it's not equals to 80. Now, when I told them it's not equals to 80, they now said, we have a confidence interval. Confidence interval, let me quickly give us. The confidence interval is, what do we mean by confidence interval? Confidence interval is when you buy a paracetamol, for example, when you buy a paracetamol, you know, after they advertise a particular drug or a particular medication, they will tell you, after 3 days, if you don't see any change, go and see who?
Consult your doctor.
Consult your doctor. They put that allowances, the confidence in the interval there, they put the space that this drug is not 100% will heal you. But after 3 days, that is where statistics comes in to everything we do. Then after 3 days, consult your doctor. We already give you our own treatment, and we are not telling you it's 100%, it will cure the disease or the malaria, the the stomach ache or whatever you have. But after 3 days, go and consult your doctor. So so you cannot take them to the courts, because when you buy the paracetamol, you still have headache. They already put it there that go and see your doctor after 3 days. That is part of the space that you have. That is why they said we give you this medication on a basis of 95% confidence interval or on 99% confidence interval. Okay, if I were you, and I said there is a drug, there is a medication for us for the pain relief, let's say pain relief, all this pain reliever medication, take is it analgesic or you call it paracetamol, and we don't have different paracetamol, brand A, brand B, brand C. One of them tell you that you have 95% confidence interval on my own drug. One of them, another one said 98% confidence interval. Another one said 99% confidence interval. Which one will you go for? Now that you have idea of what it means. Which one?
99.
99%. That is where that is the research, that is statistics. That is how we normally relate it. Yes? Who is talking? So you would rather go for the one that will give you less stress, that will not kill you, rather than the one that will affect you. So that's why when they say, that's why you see them, they've said, no, you can, if you use 2 doses of this drug, if you don't see changes, please consult this. Now, who can tell us, why is it that when you are using your own drug, your children cannot use the same dose with you? Nasiru, are you also selling drug? We can't hear you. Nasiru Buhari, are you a chemist?
It's not there.
He's there, he's talking. You want to unmute yourself. I know he's answering the customer. Okay, unmute yourself now. You can unmute yourself.
Okay.
Okay, you are selling medication.
Yes, sir.
Okay, tell us, why is it that we don't use the same drug, the same dose that you give adults, you add the children cannot use the same thing? Why?
Yes, because of age, sir.
That is just it. Because of age.
Because of age, sir.
Because of age, where do we get the age? Our age is degree of freedom. In this case, that is where you see the degree of freedom that you check for a particular thing is different from degree of freedom you check for the another one. So that is where you see that because of age, they will tell you your 6-year-old baby will only cut the dose into 2 for them, or cut the tablets into 2 for them. You can see the application of statistics in everything we are doing. So because of age, you will not allow it to happen. So let's move on. I believe those foundations will help us. So let's move on. Now, if you look at where we stopped the other time, we say that we state this hypothesis. Our mean is 78. Our standard deviation is this. Our n is this. Now, The question is, which test are we going to use? Anybody?
Z
the
test.
claim. The
Z
claim, sir.
test,
Z test.
which is Z test. You can see
Yes.
you are using Z test already, which is this. Why are we using Z test, please?
Because it's a two-tailed test.
Yeah, it's a two-tailed one.
Because the mean is better.
Because the
the mean is
sample
greater than
The
is
sample
more
is
than,
greater than 30.
yes, it's greater than 30. Are you getting it now?
Yes, sir.
This is the way, using 40 sample. Let me write it here. It's supposed to be using 40 sample here. Using 40 samples. He measured the average, blah, 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 go ahead to the end. So the same formula we are using, what has changed here is the same. So you have Z calculated. Now, we need the Z tabulated, which is alpha divided by 2. The way we do it in interval, we do the same thing here. But the difference here is we now go to the table. Can you see my table?
Yes, sir.
In my table, what is my alpha? The way you check this one, my alpha is what? Anybody?
0.05.
Now, remember that, let me go back to it. I have alpha to be this, right?
Yes.
When I divide, if I don't divide it by alpha over 2, I will have this. If I divide it by alpha over 2, I will have this, right?
0.025.
You remember this is 5%. Why this is 2.5%. Now, let's check the table. It depends on the statistical tables you provide, they give you, or you have. Let's check this one. Does it have? No. Now, you see this one, the second one that I uploaded on your platform has the negative. In case you have a negative value, you can also check it there. But in this case now, we are dealing with positive. Now, you have to be careful, please. We don't have 2.5% in this case. These are the alpha here, alpha are here. These are the alphas. So now we use 0.05 rather. Under 0.05, at where can we get, you don't need to check 0.05 in this case. What we normally check is this. Go to the table. Look for the value. What is the value of this, please? Do we all have the same value here? Look at the one I teach. Do you have it? Hello?
Yes, sir. Yes,
Do we
sir.
have this value before we proceed?
Yes. Yes, sir.
Yes, sir.
Now that we have that one, we need to check this particular one. Let me just clean this one. Just hold on. So that for those of us that if I'm explaining, you understand what I'm doing now. Now, Z tabulated is equals to 90. They said confidence interval is 95%, which is same thing as 0.95. In the case of 0.95, in the case of Z, where do we get 0.95 on the statistical table? Everybody go to your statistical table. Look for 0.95, both vertical and horizontal. Where do you get it? Let me show you. Can you see it now? Forget about the alpha, forget about the level of significance. This is not the level of significance in this case. But what you need to do is look at inside. Where do I get 0.95 or very close to 0.95? Under what?
Under 1.6.
Under
1.6.
No.
Under 0.05.
Okay. 0.05.
Yes,
Under
now under
0.9.
1.0, 1.6
Under
on the
1.5.
horizontal and then the vertical.
Some of us don't understand what we are saying. No?
Under
Some people are
0.05.
confused.
So we're
Let's
looking
check it
for
again.
0.95,
We
right?
are, yes, we are looking for 0.95.
So we have 0.9505.
Good.
Yes, that one. So
There
it
you
can be
go,
found
under
under 0.
0.5.
Yeah.
0.5. Under 0.05.
Yes, that
Okay.
is it.
That is under beside
1.6.
Okay. Please, who is not clear to what we are doing? Who is not clear to? Do we all agree with that?
I do not really understand how it happens. So.
I know. That is why I was busy asking you who is not clear to. Now, the first thing you need to know, if yes, somebody is writing something here. Okay. So, if you check very well, what is happening here is very simple. We are looking for confidence interval. We are looking for, we are given the confidence interval of, yes, Adekunle? Unmute yourself. Yes? I can't hear you, sorry. I'm sorry, I can't hear you. If you can hear me. Okay, let's continue while we are waiting for Adekunle to come back. Okay, now, two things will have happened. Are you still there, Adekunle? Okay. When you have something like this, you have to check the area of the region you are working with. What is the area we are working with in this case? The confidence level we are given is 95 confidence level. How do we solve it? Convert it to be 0.95. So who is asking the question? Then check your table. Now listen to me. The examiner can give you the table, can give you the value by themselves. They will just say Z tab or Z alpha, whatever they call it, or Z 0.95 is equals to, or let's say Z 0.975 is equals to 1.96. They already check it for you. That means you have less stress to do it. So if I said, okay, Z 0.95 is equals to 1.65. I've already checked it. I gave you, use it. So you don't need to worry yourself on that. You don't need to worry yourself on that. So in this case now, what is our table? Now, in this table, look for where you have 0.95, which is this place. That is, if you trace it to this side, you trace it to this side, look at it. This is 0.95, that is very close. Although some people can tell you that, no, I would prefer to take this one because if I approximate this one, it will give me 0.95. Both of you are right. And it's still within the same region. So you can see under what? Under 0.05. So meaning that I will have it to be I will have it to be what? 0.6 at 1.65. Do you agree with this?
Yes, sir.
Yes, sir.
Okay. Now let's move on. I gave us something from day one when we started. Look at it. At what point do we reject the H0? At what point? Now, for this particular value we have now, we need to draw let's draw the bell shape to give us the idea of what we are doing. So the bell shape will be our normal distribution table. This is 0. So we have 1.65. The 1.65 will be here. And this one will be negative 1.65. Remember, I told you they are symmetry. What is the other side will be this side. But don't forget, what is the value of Z calculated? Is what, please? Somebody should call it for us.
5.06.
Really?
Minus 5.06.
You see the negative. That is why I call it. I said you should call it. Is what?
Minus 5.0632.
Where do you think minus will be? Out of the two sides.
On the left side.
You can see now. That is where you plug it to. So it's going to be here. Minus 5.06. Let's say. That is our Z calculated. Now the question is, at this point, are we to accept or to reject the claim of the man? Do you think the man is right or the man is wrong? Because you can only reject. Look at the condition that will make you to reject. Somebody asked me yesterday night, Sir, is that the solution? I say, yes, that's the solution. The solution is this. Now, the question, are we to reject it or to accept it? Look at the condition. The condition says, don't forget about whether it's T or Z. This same condition holds for both of them. Only the alphabet that is different. The table you are using is different. At this T now, we have Z less than Z calculated. Let me put this one as Z calculated so that you will know. Z calculated and Z calculated. Then Z, change everything to Z. Now, look at the one I circled down. This is the condition. Are you saying that the man is right or the man is wrong? What are we saying with this one now?
He's wrong.
He's wrong
How?
because
The,
he's
the
less than.
claim says you can only say the man is wrong if Z calculated is less than minus Z tabulated, or Z calculated is greater than Z tabulated. Which one?
Z calculated is
is
greater
less
than Z tabulated.
Oh, really?
Z
Please,
tabulated is greater
look at
than
it. Oh,
Z calculated.
which one is the biggest? Minus 5.06 and minus 1.65. Which one is greater?
1.65. 1.65 is greater.
Is greater. Okay.
Yes, sir.
The question now says Z calculated. Let's go. Oh, sorry. Is that Z calculated? Is it less than or the way you put it?
It's less than. Less than.
Is less than Z tabulated.
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 So what do? Do we reject or we accept the H naught?
Reject.
We reject the H naught because he said reject non-hypothesis. If so, we are reject H naught if Z calculated is less than Z minus this one minus Z tabulated. So if we reject the H naught, then we will accept the man's claim. That is the meaning. That is, we reject this one, then we accept this one. Are you getting the idea now? The way you do it in practical way. You reject the normal thing that we all believe, and we accept the claim and conclude that the machine is not properly working based on the evidence. That is how we do it in real life. Yes. Yes, Faith, a gift.
Yes, sir. Why are we using the minus 1.65 instead of the 1.65?
You can use both. Let's use the second one. Don't worry. Look at it. The second one is this. They said Z calculated greater than Z with positive. Remember, positive and negative is just the direction that's different. It's still 1.65. Am I communicating?
Yes, sir.
So Z calculated is what?
Minus 5.6.
Minus 5.6 what?
32.
Does it greater than this?
No, sir.
Are you getting the point?
Yes, sir.
So either way, we're rejecting.
So either way, we are still going to reject it. Thank you. Okay. That is, by the way, that is just how you solve the problem of, what do they call it? The Z, where you have issues on Z and T. I think this particular class will be able to help us to answer some of those questions. Do we all, any question on that again? We've checked the way we look at the table, we check the table. Then before we call it a day, I only have a few minutes to go. Let's quickly touch base on F distribution. F distribution is very simple. All you need to do is know your formula, and know how to solve it. Once you know your formula, it's very simple. But there are two ways. People use different way of solving it. But I will give you simplest way that you know. Let's quickly solve it. Or are we tired?
No, sir.
Not at all. Oh. Tired.
Okay, F distribution. On F distribution, we have different formula, like I told you, of solving it. We have H naught. They can ask you to state H naught too. H naught can be sigma equals to sigma 2 equals to sigma. That is, our F is the same thing as S12 over S22. Approximately, F is the degree of freedom is N1 minus 1, N2 minus 1. Are we there? So, excuse me, how do we solve this? X1, what's the formula for X1 squared? It's the same thing as 1 all over N1 minus 1 summation X minus X bar all squared. That is what we just solved now, what we did now. Then our S2 squared, excuse me, is the same thing as 1 over N2 minus 1. Okay, we can call this one Y. Let's call this one Y. So let's look at like I told you, we have degree of freedom. Degree of freedom of here is V1 equals to N1 minus 1. V2 is equals to N2 minus 1. Degree of freedom, DF. That is our F, approximately F into V1, comma V2. So let's look at the question.
Please, I'm sorry that I'm taking you back a bit.
Okay.
I just lost the connection and I'm a bit lost. Okay, this is F distribution, right?
F what?
We've switched to F distribution.
Yes.
Okay.
Are you okay with that?
Yes, sir. Yeah, it's okay here. Let me just copy it down.
Okay. So,
thank you.
Welcome. So let's look at the example 1. In F, you only have 2 samples in most cases to be able to use F distribution. 2 random samples were drawn from 2 normal population. And their values are, A. You have 16, 17, 25, 26, 32, 34, 38, 40, 42. How many is the value, please? How many do you have there in A?
9.
9, sir.
We have 16, 17, 25, 26, 32, 34, 38,
38, 40, 42.
Okay, we have the 9. Then we have 14, 16, 24, 28, 32, 35, 37, 42, 43, 45, continuation, 47. How many do we have here?
11.
You said?
11.
11. So the question said test whether the two population have the same variance at 5% level of significance. Significance. When you hear 5% level of significance, they are giving you alpha direct. Okay, let's solve this problem. We want to test the hypothesis now. So solution will be the hypothesis. Let's write the hypothesis. H naught is sigma square 1 is equals to sigma square 2. That is our own. Then the second one is what? So we are trying to test for the two proportion, whether one is greater or one is less. Alternative will be greater than H2. So now the alternative is this. But let's look at the solution for this. How do we solve this one? F equals to x squared 1 over S22. Note that S21 x1 squared is always greater than S2 squared. So that's when, and don't forget, our S squared is the same thing as summation of X minus X bar divided by N minus 1. How do we identify X1 and S2? That is where we are going. But the condition to identify them is here. Don't forget this. Now, let's start with A. Draw the line of A. Everybody do that. Under the A, you are going to have A to be, let's tell me the value, 16, 17, 25.
25, 26,
Uh-huh.
32,
Yes.
34,
Okay.
38, 40, 42.
Okay. Somebody should sum them together. Add it together, please. Because we need it to calculate X minus X bar A for A. Then we now need to square it. X minus X bar of A squared.
That's 270.
So the first 270, right?
Yes.
Thank you. Then we need X bar A, 270. You know, X bar A is the same thing as summation of XA divided by N. What is summation of SA?
Yes, sir.
270 divided by what? Please talk. How many did you add together?
9.
What's the value?
30.
Thank you. So it simply means our X bar is 30. Thank you. So we now have 30 minus, you now be deducting it. This is X. 16 minus 30 is what?
Minus 14.
Minus 14. Then let's continue. 17 minus 13. Minus 13.
Minus 13.
Uh-huh.
Minus 5.
Minus 5.
Minus 4.
Minus 4.
2.
Plus 2.
4. Plus 4.
Plus 4.
Plus 8. Plus 10. Plus 12.
You don't need the summation for that. So let's now square it one by one. 14 minus 14 squared will give you positive.
96.
196.
Yes, next.
169.
Yes.
25, 16, 4, 16, 64.
100.
100.
So add this one together. What do you have? What do you have? $734. Is it true? Confirm. 734. So we need now that we have 734, remember the formula of S squared is saying summation of X minus XA bar squared divided by N minus 1. What's the value? 734 divided by
734 divided by 8.
Divided by 9 minus 1.
Divided by 9 minus 1, which is 8.
What's the value? 90 what?
91.75.
Good. Now, every one of us will do the same thing for X, for B now.
Yes.
Our B, can we call the B for me? The second proportion. 14,
16, 24, 24, 28, 32, 32, 35, 37, 42, 43, 45, 47.
Good. So add it together. What do you have? So I will not write it down. I want you to do it in your notes. Everybody do it. I have my solution. So what is XB now? We want to calculate XB. Anybody? How many value do we have in B?
11. B is 11.
B is 11, yes. So anything we are doing divided by 11.
X bar is 33.
Is what?
33.
No,
33.
what is, tell me the value first.
Okay.
363.
Divided by 11.
Yes, sir.
Good, thank you, sir. So let's do the, now we will be using 33 minus XB. So let's do it in your notes and square it at the same time. Let's see the fastest hand or the fastest finger, you call it.
The first one is 361.
No, you do it now. Me, I don't want to
Oh, the
write
total.
it. I need the total. Do it by yourself. I need the total.
Minus.
Where you get minus, keep your minus to yourself. Don't mention minus. Where will you get minus? Remember, you have to square it. So you have to do
How do we arrive here? Oh, my data went off. Oh, what happened? Why are we here? Miss, what are we working on now? Because I didn't follow. Can anyone hear me?
I watched the recording. After I watched the recording.
anybody, any luck? All you need to do is, yes.
1,000.
650.
Which one?
That's XB squared.
You said 6 is what?
50.
No, what I need is just, I need the total value for summation x minus xb. What is the total value? Tell me.
1,298.
1,298.
Correct. 1,298. Correct. So divided by n minus 1.
129.8.
What is n minus 1 in this case?
10.
11 minus
11
1,
minus 1.
which is 10.
Which is 10. That is, we have
Yes.
it to be
129.6.
128,298 divided by 10. One what?
129.8.
Good. Now, remember the law says, yeah, thank you. Remember the law says something. It says, look at the law. It said S2, X1, the one you will use for X1 squared must greater than the one you use for S2.
For S2.
So out of the two values now that we have, which one do you think we can use for X1? Our X1 will be what now?
Our S1 is S2.
B.
Is B. What's the value for B,
Yes.
please? 129.
129.8.
And S2 squared is what?
91.75.
Good. So F distribution is no more than that. So they now ask us to get our F calculated. F calculated is the same thing as S1 squared over S2 squared. What is S1 squared? 129.8 divided by 91.75. What's the answer, please? Somebody tell us answer.
1.414.
1.414. 414. Are you sure?
Sir.
Okay, that's F calculated in case we get another one. Now, we need F tabulated. Remember, F tabulated is the same thing as F alpha, comma, V1, comma, V2. That's the degree of freedom. So it's going to be, what is our V1? Our V1 is N1 minus 1, which is the same thing as, what is N1 now? Which one is our X1? Will be our N1. So use it.
So that will be 11 minus 1. 11 minus 1, which is 10.
11 minus 1, which is 10. Thank you. V2 will be what?
9 minus 1.
Now,
8.
What is our alpha? Our alpha is what?
Please scroll down here.
0.05. 0.05.
Check your question. Alpha is here.
Okay. 0.05.
0.05.
Yes, sir.
Okay. So what is the solution to that? So we go to the, let's check before then, let's write it out the way we're supposed to do it.
Sir, please scroll down. No.
Okay.
He's trying to scroll down. Oh.
The board is too big, you know that. So if I didn't get it again, I will you just watch the video to get this thing can be annoying. You see where it took me to now. Let's just be taking it after the other, one after the other like this. I'm not sure whether it's still up.
Page, if we know the page, we will.
It doesn't page. I don't page it.
Wow.
I don't page it.
I think
it's the same place. Everything will be on the same page.
We're former classes.
Press the control button and scroll your listening.
Okay, just press it from there now. You see which control button? See this woman. See, look at today's own now.
You're going down, yes. Down.
I know it was down after this.
Price index. We've done this before.
You know, when you know how to drive and you sit in the front, and when the person is driving you when the person marks the brake, you mark the brake. You also mark the brake in your mind. Say, oh, this guy's supposed to mark the brake here. You match it. That is what is happening now. She said I should press the control button. We are pressing control. Or are you also the secretary? Tell us now whether you are the general secretary. I know I've gone far. Let me try. If I see it, if not, no problem. All you need to do is just, you know the method. Oh, here he is. Yeah, you can see. So all we need to do is F 0.05, comma 10, comma 8. Let's check our table. Let's check the F table there. Look at it now. Look at the way they put the F table. Is for 0.5, is 5. Can you see the table?
Yes, sir.
Yes, sir, but it's not clear.
It's not what?
Clear, sir.
Don't worry. It's your network. It will clear. By the time I remove it, it will be clear.
Yes, sir.
Oh, okay. Now, what is our V1?
10.
You see, they did not give us 11.
Yes, sir.
So don't ask me that why. That is why they give you n-1. You see 10 and the V2, 8.
V2, 8.
Go and check 10 under 8.
3.35.
You see, it is very straightforward.
3.35.
This is where we are. So, can I highlight it? You can see this one.
It won't allow you, sir. It's going to do row by row.
Have you seen it? So 3.5, 3.35 is your F tabulated. So go back, you write it, 3.35. Now let's assume, peradventure you made a mistake. Look at this. Let's say you change this one to 8, you put this one for 10. Do you still get the same answer?
No, sir.
Be careful. Make sure you identify it clearly. So we conclude. Calculated value of F is smaller than tabulated value. So what do? H naught is accepted. H naught is accepted.
It's accepted.
Yes. So look at it. F tabulated, our F tabulated is equals to 1.414, right?
Yes, sir.
Is less than.
That is F calculated, sir.
I thought it's F calculated.
Thank
I
you.
was wondering.
Calculated. Thank you. I
F
mentioned
calculated.
calculated, but I'm writing tabulated.
Tabulated.
It's less than. I'm tired, guys.
Sorry,
Sorry,
sir.
sir.
Yeah,
We'll
try,
send you.
sir.
We'll send you shawarma from Nigeria.
Okay, keep it up. So we have this. So our F calculated is less than F tabulated. Therefore, H naught is accepted. Hence, we can say that the two populations have same variance. We can say that the two populations have the same variance. What is variance? Variance is what we have here. Look at it. We did something on the variance. This is our variance. This is what we call variance. They have the same variance. That's why they equal. Remember, we accept H naught in this case. If it is other way around, that means we will say there is a difference between the variance. But in this case, the variance are the same. Thank you so much. Any question? Yes. Go ahead.
Okay. Thank you so much, sir.
You're welcome, sir.
I just noticed on this F table that we only have 5% significance level and 1% significance level. Does it mean that we don't have anything like 10% significance level on the F table?
We don't have in most cases because they only have a kind of standard one. In most cases, they have a kind of standard one. In advanced level, you will see different one. But as far as this is concerned, the table that is available for now is the one that I just showed you. Then the examiner can change his mind and give you another thing. It's possible. Just follow, like I told you, follow what you were given and apply it accordingly.
Thank you so much, sir.
You're welcome, sir. Gifts, over to you.
Yes, sir. Sorry, sir. The two populations have the same variance.
Yes. It simply means that we accept the H naught because the F calculated is less than F tabulated. Hence, we conclude that the two populations have the same variance.
Okay, the variance is not a figure.
You said?
Variance is not a particular figure.
No. Variance is like the way we are talking about mu. You remember when we did statistics in first semester, we are doing standard deviation, we are doing variance and some other things.
Yes, sir. And we only get figure at the end of the day.
No. In this case, it's not a figure, it's just a representation. Because we are trying to check if you look at the form, the work, we are trying to check. Let me go back to it. We are trying to check the variance. Let's look at the question. Let's read the question. Look at it. The question says, test whether the two populations have the same variance. Are you following me now?
Yes, sir.
The question might say, test whether the population, the two populations have the same lot or have the same anything. But in this case, for F distribution, we test variance in F distribution. And I would advise you guys, go and read more about F distribution. Look at the way they represent it too, in variance format. You're welcome. Somebody else raised up their hands. Who else? Any other question?